This is AS Module 2, January 08 paper, and it's question 3 and the topic is lenses. Your data and formula sheet quotes the lens equation, 1 over u plus 1 over v equals 1 over f. In this equation, what do the symbols u and v represent? Very straightforward, 1 mark for having both of these correct. This is the distance of the object for u from the lens, and v is the distance of the image from the lens. What type of lens would have a negative value of f? Again, straightforward learning this. It's a diverging lens. 1 mark for having both of these correct. If you got one part of it wrong, then you would lose the full mark, and a mark for saying diverging. State very briefly how you could distinguish practically between a real image and a virtual image. Well, a real image can be captured on a screen, a virtual cannot. And it would always be good practice to state both parts of that in the question. So when you state briefly how you could distinguish practically between a real image and a virtual image, you should say what happens to the real image and then what happens to the virtual. So a real image can be captured on a screen, which could be something as simple as a sheet of white paper, and a virtual image cannot. Part B then refers to the diagram. Figure 3.1 is a set of axes labelled 1 over u and 1 over v respectively. The scale used for the 1 over v axis is the same as that for the 1 over u axis. So that's an unusual piece of information that must be very relevant to this question. So the scale for both axes are the same. On the axis of figure 3.1, draw a graph of 1 over v against 1 over u for a converging lens, and then describe how an accurate value of the focal length of the lens can be deduced from this graph. So we have to draw a graph and then use it. Well, on the graph, firstly it tells you the scale is the same for both. And our graph is a straight line with a -1 intercept. Whenever we look at the lens law equation, if we say that 1 over f equals 1 over u plus 1 over v, if we rearrange that then to have it in the form of y equals mx plus c, the y-axis is 1 over v is equal to minus 1 over u plus 1 over f when we rearrange this equation. So the y-axis is 1 over v, the x-axis is 1 over u, so the gradient we're expecting is a minus. This also tells us then that the intercept will give us 1 over f. And our question at the bottom is to describe how an accurate value of the focal length of the lens can be deduced. So it's something to do with the intercept. Now, because the scale is the same on both axes, we're going to draw a line with a gradient of -1, but it should meet the axis at the same point along the graph. So I'm going to take 5 centimetres up here, 1, 2, 3, I'll take 4 and put a dot. Going to do the same on the x-axis, measure 4 centimetres. You can pick any 2 points that you choose as long as they're equal, and then join those 2 points. That gives us a gradient of -1. So these length on the vertical axis and the length on the horizontal axis must be equal because the information in the question tells you the scale is the same. On the axis, draw the graph. We've done that. Now describe how an accurate value of the focal length of the lens can be deduced from this graph. Well, we've already said that the y-intercept will give us 1 over f, and because the scales are the same, the x-intercept will also give that. So the first thing we can say is the focal length is equal to 1 over the intercept on either axis. So you could call this the reciprocal. Now it talks about an accurate value. Now according to the mark scheme, there's 1 mark for the graph, there's 1 mark for saying this, and there's 3 marks for the question, so we need something else, and it's to do with that accuracy. What we should do is take both intercepts and find the average. And that's where the idea of the accurate value of the focal length comes in for the 3rd mark. Moving on to part C of this question then. Part C says a stamp collector holds a lens of focal length plus 20.0 centimetre at a distance of 12.5 centimetres from a postage stamp in order to study lettering. Find the numerical value of the linear magnification of the lens when used in this way. We've got F and we've got U. That would lead us to use the lens law equation. 1 over F equals 1 over U plus 1 over V. So 1 over 20 is equal to 1 over 12.5 plus 1 over V. When we rearrange that and work that out, we find that V is 33.3 centimetres in this case. We're interested to find the linear magnification. So M is equal to V over U. So 33.3 divided by 12.5, and when we work that out, we get a value of 2.66. Remember, there's no units for magnification, but we must be consistent in the units that we use for V and U. They must be able to cancel. The marks for that question then, you had 1 mark for substituting correctly into the lens law equation, 1 mark for finding V, 1 mark then for writing the magnification equation, and the final mark for working that out. So to summarise that question then, we had to define the terms of the lens law, identify what lens would have a negative value of focal length, distinguish between a real and a virtual image, then draw a graph representing the lens law, and describe how we could find the focal length from that. And the key to the marks there was the accurate value of focal length, and that means that we must average the 2 intercept values. And finally, we were to find the linear magnification of a lens, which involved using the lens law first of all to find the image, distance, and then substituting that into the magnification equation.